All right, so 9.6, solving right triangles. Before we do that, I want to change this number right here for easy math, just it's going to make your life easier, to 25. Okay, so it says find the value of x. So let's just worry about that first. So we have a right triangle. Always identify the hypotenuse first. All right, it doesn't matter a and b. So basically I have 7 squared plus x squared equals 25 squared. Because remember, my hypotenuse is always c. All right, so that gives me 49 plus x squared equals 625. So we subtract 49 from both sides, and we get x squared equals 576. Now when we square root both sides, that goes away, and we end up with x equals 24. So x is 24. So now we have our 3 sides. Now let's deal with the actual math of this section, which is finding sine, cosine, and tangent of this funky little symbol here. This symbol is the Greek letter theta. Not really important, just, I'll probably refer to it as theta. Often though, I'll just refer to it as the angle. Okay, so here's the angle right here. We're talking about this angle right here. So remember, sine is so, opposite over hypotenuse. Cosine is ka, adjacent over hypotenuse. And tangent is toa, opposite over adjacent. So remember, from this angle, let's just do sine first. Sorry about that. We'll do sine first. So sine is opposite over hypotenuse. So from this angle, the opposite is way over here, 7, and my hypotenuse is clearly 25. So remember, anywhere we have h, we're going to be putting 25. Now O and A, it depends on where we're looking from, okay? But hypotenuse is constant. It's always the same place. So the sine of theta equals opposite over hypotenuse. And then we just turn that into a decimal. 7 divided by 25, 0.28. So nope, that's not right, because again, I have to change this every time. You do not. Sorry about that. But that's how it makes sense. Little common sense kicked into my brain and said, hey, there's no way this angle is 0.28, less than 1 degree. So I'm going to try this again. Oh, no, 0.28 is correct. I have to do the inverse sine, because I'm trying to find the angle. Sorry, my brain is a little off. So the way we do that is we're going to do the inverse sine. So we hit this button, sine, and we say 0.28. And we'll round that and say theta, or the angle, is 16.3 degrees. Now, I just want to show you on the calculator, you did not have to do the division first. You could do second sine, inverse sine, and then just type in 7 divided by 25 here. You don't have to do it in 2 steps. Okay, but that change in my calculator I made, I did have to do that anyway, because otherwise this would not have worked. So this was correct, but that change has to be made, but we've already done that to our calculators. Okay, so now the cosine. So remember, cosine of the angle is the adjacent over the hypotenuse. So what is adjacent to here? 24. So 24, and again, 25 does not change. So we're going to go back to our calculator. Now this time we're going to do second cosine. We always do the second button when we're trying to find the angle. Okay, so cosine, and we just type in 24 divided by 25, close the parentheses. Now, why do we get the same answer? Because we're talking about the same angle, okay? So theta is obviously 16.3 degrees, but I'm just showing you how you could get it using any of the combinations. So toa, tangent, you already know what the answer is going to be. The tangent of theta is opposite over adjacent. That's supposed to be a 4. And so when we type this in and do second tangent, this time 7 divided by 24. There you go, same angle, which it should be because it is the same angle we're measuring. But there's how you could find it using any of the 3 sine, cosine, or tangent. All right, determine which of the 2 acute angles has a cosine of 0.5. Okay, so remember cosine is adjacent over hypotenuse. So we're going to go from A first. So the cosine of theta, and I'll put an A up here to remind ourselves we're doing A, is adjacent over the hypotenuse. We always want to know where the hypotenuse is. So the square root of 3 over 2. And from the other angle, cosine of theta, we're going to do that B, adjacent would be right here, 1 over 2. Now, without doing any calculations over here, we already know that 1 divided by 2 is 0.5. So it's angle B. But if you didn't set this up ahead of time first, and you would have done this, very simple. Second cosine, and we just type in second square root of 3. Nope, did not mean to do that. Come out of that, divided by 2. So square root of 3 divided by 2, and we get 30. All right, moving on. So, like I already said, when you're trying to find the angle, I've already introduced this, it's called the inverse ratio, okay? So the inverse tangent, that's why when you saw in the calculator that little -1 there, okay? When we're trying to find the angle, we always use the inverse of these operations. So let A, B, and C be acute angles. Use a calculator to approximate the measure of A, B, and C to the nearest tenth of a degree. So all we're doing here is typing in the calculator. That's all we're doing. It's straight calculator work. So we're trying to find this angle here. So we're going to hit second tangent and just type in 0.75. 0.75. And it says round to the nearest tenth of a degree. So 6 makes this 9, so 36.9 degrees. Right? This time we're doing inverse sine because we're trying to find the angle. So second sine, what was it, 0.87? 0.87. Nope. 0.87. The 5 makes the 4 round up, so 60.5 degrees. We're finding the degree. And last but not least, cosine. We're going to do second cosine, the inverse cosine of 0.15. Seven makes the 3 round up, so that's 81.4. Right? Simple calculator work. All right, to solve a right triangle means to find all unknown side lengths and angle measures. You can solve a right triangle when you know either of the following. 2 side lengths, okay, then we would do a squared plus b squared equals c squared, or 1 side length and the measure of a triangle, 1 acute angle, which means we'd use sine, cosine, or tangent. So, solve the right triangle. So in this case, since we have both legs, we're going to do a squared plus b squared equals c squared. Okay, so 2 squared plus 3 squared equals c squared. So that's 4 plus 9 equals c squared. That's 13. Sorry, got ahead of myself. Equals c squared. We're going to square root both sides. So c is equal to the square root of 13. All right? So this is the square root of 13. We're going to leave it like that. We're not going to round it. We're just going to leave it like that. Now, it also says you want to find all the angle measures. So we need to find B and A. Okay? So, for B and A, make your life easy. If you use so or ka, you have to use hypotenuse, which is a nasty number. Just use these two numbers. Okay? So we're going to do TOA. So the tangent of, let's go with B first. I don't know why. Tangent of B is equal to opposite 2 over 3. So we just go to our calculator and type in second tangent, 2 divided by 3. All right, and then it says round in the nearest tenth, so that's 33.7. degrees. And then tangent of A, again from A, the opposite is 3, and the adjacent is 2. So we're going to type in second tangent, 3 divided by 2. And that gives us 56.3 degrees. Oops, I wrote A up here when it's supposed to be B. A equals 56.3 degrees. And if you notice, these two add up to 90. Okay? Now, I could have done sine or cosine for either one of those and used the square root of 13, and there's nothing wrong with that. It's more steps, it's a little more complicated, so why not make your life easy and use the numbers that make it easier for you? All right, number 4, second to last one. On this one, solve the right triangle. So we only have one side, and that side is the hypotenuse. We do have an angle, though. Okay? So since we have the hypotenuse, we need to do sine or cosine. I don't know why I put an O there. Okay? SOHCAHTOA, sine or cosine. Opposite over hypotenuse, adjacent over hypotenuse. So from H, right, opposite is right there. So, and the hypotenuse is right here. So sine of 25 equals H, or X, doesn't matter, over 13. Now remember, this is the easy one where you just simply multiply by 13 on both sides. So on a calculator, all we do is type in 13 times the sine of 25. Easy peasy. Okay, so round to the nearest tenth, that's 5.5. So H is 5.5. Now, cosine of 25 is adjacent. Well, that's G over 13. So again, this is the easy one where you just multiply by 13 on both sides, and we just type that in. (13 times cosine of 25). And we get 11.8. Okay, so now we know our side lengths. And then to find the other angle, G, all we need to do is add 90 plus 25, and then do 180 minus 115 to get the missing angle of 65. So angle G is 65 degrees. All right, last but not least, your school is building a raked stage. The stage will be 30 feet long, so from front to back, with a total rise of 2 feet. You want the rake angle to be 5 degrees or less for safety, all right? is this rate stage okay? So we're trying to find out if this angle here is less than 5 degrees. So from that angle, we have opposite and hypotenuse. Well, that's going to be sine. So sine of, again, you can put theta, you can put x, whatever you want, equals 2 over 30. We just type it in our calculator, invert, sorry, wrong button. So second sine, the inverse, and that was 2 divided by 30. 3.8. So x is 3.8 degrees, which is less than 5 degrees. So yes. And that is it.